I think it's number 6 or
Tell me
7.
where my McGriddle on here.
All right. So here we go. Let's start with my review sheet, and then we'll do his. Because mine is a little more comprehensive. I need to take attendance. Because it's not just 12 to 14. It's, wait. Is it, Cole's a junior, right?
Yeah.
He's usually in my Spanish class.
Yeah, maybe put it on there if you want. And let you pick up more shit. Phil.
Avery's over there. Oh, wow. I'm erasing something just like we're doing with problem number 1. So there's a lot going on in problem number 1. You got it. What's the first thing you're going to do with problem number 1? Factor it. You're going to factor the whole shebang as best you can. So it looks like the bottom's easy, right? And the top, it looks like I'm gonna factor by grouping maybe, right? So x squared, x minus 3, minus 4, x minus 3. How does that look, everybody? Right, is that okay? So my common factor is x minus 3. And then I'm gonna factor that difference of squares. So, how are we with the factoring? Did I make a mistake or am I all good? Well, you were supposed to pick them up when you came in. Okay? Now, factoring okay? Am I good with factoring? Okay. Now, what do you notice right away? Hopefully you notice that there's going to be a hole in this picture. So I'm going to go ahead and write what I have left, because this will be the focus of my problem now. I mean, this is where my attention will be. But before I forget, I'm going to go ahead and put my hole in, because sometimes I get carried away here and forget about it. So where will my hole be? Remember, it's a point. So the hole will be a point where x is 3, because that's the factor that I canceled out. And then how will I find the y? The hole's a point, I gotta have a y. Plug it in right here, right? So if I plug it in right there, if I plug in 3, I'm gonna get 5 times 1 over 8. Did you get 5/8?
I got 5, 6.
Where did I plug in? Oh, not 5, I plugged in 3. Yep, thank you. 5, 6. Thank you. So if I plug in 3, that awful day here. 5, 6. Right, am I okay? To here. Okay. I'm supposed to list the holes, done. Now I got asymptotes. Now, is there going to be a vertical asymptote? Absolutely there is. because we have a denominator. And if x is -3, we are in heap big trouble. So my vertical asymptote is x equals -3. Now be careful. Am I gonna have a horizontal asymptote? No. Isn't my power on top one bigger than my power on the bottom? So that means I will have a slant asymptote.
Yeah.
And I find slant asymptotes by division. So I'm gonna go ahead and multiply this back out. I'm gonna be dividing x squared minus 4, that's my numerator, by x plus 3. That's the division that I'm going to be doing. So in my little box, I'll put a -3, I'm doing my division. Now I'm very careful here. This is gonna be 1, 0, -4. And I'll do my division. And remember that I don't even care about the remainder at all. What do I need? Just my quotient. And that represents y equals x minus 3. So that's my horizontal asymptote. That's the equation y equals x minus 3. So we got our whole, our removable discontinuity. We have our asymptotes. And now we need the intercepts. How do we get a y-intercept? 0 in, right? So if I come back over here or somewhere and plug in 0, it looks like I get -4/3. Double check my math on that. And how do I get my x-intercepts? Where do they come from? They come from the top, from the numerator. So if I look at it in factored form, it's pretty easy to see my x-intercepts are going to be at -2 and 2. Now, based on your experience, and you haven't done a ton of these, but you've done a few, do you have an idea what this thing looks like?
Upward little thing.
You know these dots have to be connected, right? Look, you've got 1, 2, 3, 4 dots that have to be connected. Doesn't it make sense that it would look like this?
Yeah.
It follows this asymptote up and this asymptote out. But remember, the vertical asymptote right here splits the paper. And you've drawn the right side of the picture. That's drawn. What is happening over here on the left?
The little bottom thing.
This little piece right down here. You can't cross the x-axis anywhere but here. So it doesn't make sense for you to try to draw something up here. That doesn't make sense. It has to be down there. All right. Unit 1, polynomial and rational functions. That's a rational function. We good? All right, what's number 2? Okay, now we're gonna get our calculator out. And we're going to do, this problem continues on to the next page, okay? Okay, so we're gonna type it in. And everybody remembers how to type it in and stat edit. Do we have it in? Did we come up with our equation? Alright, so our equation, I don't know, here's what I got, see if this is what you got. I got y equals negative 2.881, does that look right? Okay, x squared plus 11.190x minus 11.5. And I'm gonna note, I have an r squared of 0.99928. So if I were asked, which I don't think I am, but if I were asked, what percentage of the data does the model, of the variance does the model explain? You would say 99.928%, right? Okay. Find a quadratic model for data, done. Does the model over or underestimate at x equals 3? How could we tell real easily? Declan? Check the residual. And isn't the residual in my calculator? So one way to do it is just to go back to stat, edit, and click over, and we want 3. Which is, I got negative 0.1429, is that what it is? 0.1429 negative. Am I okay there? Do you want me to get away with it? Is that all right? Okay. Now what does that mean? Does the model over or estimate and explain? If the residual is negative, remember, residual is actual minus predicted. So if that comes out negative, what does that mean? That means the prediction was too big. We overestimated.
Where's the residual at on your calculator again?
L7 or L6, whatever list you made it back when we changed it to when we renamed it residual.
But like, how do I?
Oh, you'll have to wait.
Okay.
That ship has sailed.
What would you like say in your explanation?
So what would I say, Gus? What would I say?
Say it as negative?
Well, I can see that it's negative. So I would say, it says so the residual is negative 0.1429. What does that mean?
That you overestimate?
The model overestimates.
That's your explanation?
Yeah. At that particular point, the model overestimates. All right, now we need a residual plot. All right, we haven't done one of these in a couple of days. Who remembers how we do a residual plot? Well, first we gotta go to stat plot. And we gotta turn, I don't know if your plot's on or off, but you gotta turn it on. And then make sure that X list is L1 and that Y list is residual. And then you may not see what you want to see, so remember how we fixed that? We press zoom, stack. And I got a plot that looks something like this. And because I entered 7 data points, I should have 7 dots on my picture, right? And this would be a good residual because it's balanced. Remember we talked about that? If they're all positive, then you've got a bad model. All right, D. Find G of 5. So G is this equation right here that you got. Could you get the answer by plugging 5 into that right there? Yes, but you're risking round off, right? So what do we do instead? We go to vars, get our y, and then what number are we putting in? 5. Did you get negative 27.571? I can't remember if you guys in the other group said, how close do we have to be? We're right on. There is no reason for there to be no inaccuracy, because our calculators are doing all the work, and yours is just like mine. Got that one? Okay. Then we want to find x, so g of x is negative 100. Okay, now that does not mean this. Does everybody understand that? This is not what you're doing. This is a y value. So what's your thought about that? Al?
You could graph y equals negative 100 and find where it intersects.
Exactly. So if you, right now at this moment, if you press y equals, that equation is in there, because you stored it. So if you just add negative 100 as y2 and hit graph, now it's not going to be right. We're going to have to adjust our window. Gotta go down to at least out of down to negative 150. What happened?
It intersected twice.
It intersects twice. Does that make sense? Yeah. What shape was our model? Parabola. And we drew a line through it. Aren't there 2 places where it's going to equal negative 100? Now, in a word problem, we might not want both of them because maybe the negative one wouldn't make sense. But this is not a word problem. So there are going to be 2 answers. And we'll find those with second calc intersect. I got one of them to be negative 3.931. Anybody else get that? Negative 3.931?
Yeah.
And then, I haven't done the other one yet. Marker. 7.815? Everybody okay? All right, number 3. Got this funky looking picture here. True or false? All right, so we've got 3 statements about this picture, and we're going to decide if they are true or false. All right. A of x is negative and concave up from -5 to -1. True or false?
True.
Absolutely true. When we say a of x is negative, that means the y's are negative? And they are. Perfect. All right, so that's the true. All right. The rate of change of a of x is decreasing from 0 to 5. Why do you say false? It's not concave down the whole time. Remember, if the rate of change is decreasing, we are concave down. But this picture has some concave up in it, in that interval, so that would be a false. A of x has a point of inflection at x equals -5.
True.
A point of inflection is a point where what happens? Concavity changes. We go from being concave down to concave up. True. Good work, you guys. A of x is positive, and its rate of change is positive from 5 to 10.
False.
Why do you say false? A bunch of it's negative, right? It's under the y-axis, or under the x-axis, so the y's are negative. That's a false. Perfect. All right, number 4. Selected values of a continuous function are shown in the table. Use the values in the table to answer the questions. All right, we're going to find g of 1. Now, we've talked about this before, and you know how crazy I get when we make this problem harder than it is. It says find g of 1, so we're just going to plug in 1, right? So what does it say? 3f of 3 minus 1, if I plug in 1. And then I should be able to look at my chart. Do I know what f of 3 is? I surely do. F of 3 is 5. So the answer to the problem is 14. Find k if g of k is -7. That means that the value of the function is -7. So what does the function look like? 3f of x plus 2 minus 1 has to equal -7. Isn't this my g of x function? So what should we do there? Add 1. So 3 f of x plus 2 equals -6. And f of x plus 2 then must equal -2. Now, I don't care what this is, call it whatever you want. F of it is -2. what is the only number we can plug in to F and get -2? The only number we can plug in is 8, isn't it? Doesn't, under my hand, doesn't it have to be 8? Okay, but what's under my hand is actually x plus 2. So if x plus 2 has to be 8, then x must be 6. I called it x, they called it k, it doesn't make any difference, it is 6. All right, B, part B uses the same chart of numbers. Let P be the function that results from applying 3 transformations to the graph of F. Okay, so what's the first thing you're probably going to want to do?
Find the equation.
Find the equation, or the rule, the formula, whatever you want to call it. We got to figure out what in the heck P looks like. So what does P look like if we are horizontal dilation by a factor of 3? What does that mean? Horizontal,
Negative
there won't be any negatives at this point. There might be in a minute, but I'm doing them in order. So I'm starting with what's my horizontal dilation?
1/3
F.
F.
So that's gonna be F of 1/3 x. Okay? And then a reflection over the x-axis.
Is that a negative
That's a
outside?
negative outside. Because if you're reflecting over the x-axis, aren't you changing the sign on y? And then a vertical translation by -4. -4. And this is our function P now. This is P. Everybody okay with that? There was a problem like this in the homework, which I'm gonna return here in a little bit, if I remember. And some of you missed that entire section of problems because you had your rule wrong. You did this part wrong. So we gotta make sure we have this part okay. Everybody good? All right, now we're gonna find P of 3, so we're gonna plug in 3. So negative F of 1. Is that right? Okay, and what's F of 1?
7.
F of 1 is 7, so -7. Did you get -11?
Yep.
Alright, find x if P of x equals F of x. What do you think about that? Al?
What do we plug in for P of x, negative F, 1/3 x?
So in other words, what it is, so negative F of 1/3 x minus 4. Okay?
Divide. Can you divide F?
No, that's not, no, you can't divide by F. You can divide by a negative, you can add 4, you can do all kinds of stuff. So if you wanted to, and I don't know, this is kind of tricky here, but we could add the 4 and then divide by the negative. And then I think we might just wanna think about this for a second. If these guys are gonna be equal to each other, and remember, F is defined by this chart right here. We could do some trial and error. For example, if X is, I'm looking at my list of possible X's. If X is -3, then this would say that F of -1 is the same as negative F of -3 minus 4. You see what I'm doing? I'm going to just check to see which numbers in my chart, which is how F is defined. These are my F values. This is it. Is that true? Does that work? Well, what's F of -1? That would be -5. F of -3 is 1, so this would, oh my gosh. Did I get it right on the first one? That works, doesn't it? Now, I didn't think that was gonna work, so I was prepared to go to the next one, which would be F of 0. I'm gonna put in 0. Now, why am I picking numbers like -3 and 0? Because I can't have fractions, right? I can't have any fractions, because there's no fractions in my chart. So I'm picking numbers that are divisible by 3. So this formula, if I let X be 0, would say F of 0 equals negative F of 0 minus 4. That's what this would say. And I don't think that's gonna be true, because F of 0 is -1, and that doesn't work, does it? So it's not 0. Well, I already know, because I got lucky, it's -1, or no, -3, X was -3. But if those two didn't work, then I would have tried 3, and just plugged it in to see if it worked in my little formula, and then I would have tried 9, and hopefully something like that.
So we pretty much just have to guess and check.
Yes, but I'm guessing smart. I'm not guessing every single X value in my thing. But that's the only way I can figure out how to do it. There's probably another way, I just don't see it. You might see it.
No. If P of X equals F of X, are the functions equal?
The transformed function has the same output as the original function for one value of X.
Okay, just one value?
Not in general, yeah, for one value of X.
Okay, I thought for a second it would be like all solutions because
No,
they equal.
no. Think about, in the homework, there was some problems where the original was graphed, and then you had to draw the transformation.
Yeah.
Sometimes they cross. And what happens where they cross? That's where they're equal to each other. So you're basically figuring out where does this graph cross this graph.
Okay.
Except this isn't really a graph, it's just a set of
Numbers.
ordered pairs. Yeah,
Alright, I get it.
okay? All right, speaking of graphing, let's see what you can come up with for number 5, and we'll have one of you come up and put your thing on the board. So I'll sketch the original up here. You start working on it. This is F of X. F of X is the original. And you are going to sketch G of X. did you figure out what transformation is doing? Let's make a list of the changes. I wrote it this way, I like to have my number on the end, so I wrote it this way. What's happening? What are the transformations that are going on here? Okay, so we multiplied y by -1 or flipped over x-axis. Okay, what else did we do?
You added one, so you want up one.
Up 1, so y plus 1, we added 1 to the y's.
X's are divided by 2.
And the x's are divided by 2 or multiplied by half. So the only one of these that impacts the x's is that one. So my x's become -2, 0, 1, 2, and 3. Does that make sense to everybody? They got divided by 2. Now, 2 things are changing the y's. Which has to happen first? Which of these happens first? PEMDAS.
Flip.
We do the -1 first, so we flip it, -1, and then add 1. So if you make this positive and add 1, it will be at 5. If you make this positive and add 1, make this negative and add 1, negative and add 1. How does that look to everybody? Is that okay? So now when I plot my new points, I have -2, 5. Zero, 1. 1, -1. 2, 1. And was that 3, 1? Did I do that one wrong? That one should be -1 now. Thank you, because that was -2 plus 1. That's there. So what is it? Did you get something to look like that? You don't have to do it point by point like that, but sometimes that's easier.
Why did you do like the origin?
I just did, because I had it.
Oh, okay.
I mean, it's not gonna hurt anything. I can do as many
Yeah.
points as I want. Okay, number 6. Write a linear model for the data. What percent of the variation is explained? Okay, there's a whole bunch of parts to this, so kind of read through all the parts. Here we go.
When we have the years like this, does the first year, like you said, would it be 0 or 1?
Well, there's no directions that say, so I'm just gonna go ahead and use the numbers in the chart. So, sometimes it says in the problem, let X be, and then you gotta define it that way. But here, it doesn't matter. So it might make it easier when I answer the questions, just to leave it this way. What am I doing? Step. exactly as presented in the problem. I didn't modify anything. And my equation came out to be this, 18.225x minus 36343.511. How does that look? Does yours look like that?
Yep.
Now, Gus's question was, sometimes when we do this, we don't put the data in exactly as it is. We have to change it. But when we make those changes, it's according to the directions. If you change your x's and make those, 1, 2, 3, or whatever you make them, you have to make a note of that. You have to write that down, because the assumption will be you're going to enter the data that you've been given. So there's my equation. The percent of the variation explained by the model, that's R squared, guys. Remember, use R squared. So 99.570%. The residual for 2002, that was one of my entry numbers, right? Yep. So what's our residual for 2002? Negative 2.139. Negative 2.139. What does that mean? Our model overestimated the number of subscribers in 2002 by about 2 million. You hear that? Our model overestimated the number of subscribers by about 2 million. And then a residual plot. So again, we did that earlier. We gotta go to step plot. Make sure we're all set up with L2 or Y list. Y list should be residual. You'll probably have to zoom stat to get something. And did you get a nice little plot? I got 3 dots on top and 4 on the bottom. We okay with that? Perfect. All right. And then finally, we've got this thing I drew. We're going to answer some questions. So take a couple minutes and fill in your answers, and then we're going to check them.
What does C tell you? Overestimate. What? About. Lisa, you got yours done? All right, ma'am, here we go. You're into the first one. The limit as x approaches infinity
she said -3 from the top. And she's exactly right. Because x approaching infinity means go that way off the page, right? And what's your curve doing? It's doing what they do. It's getting closer to its horizontal asymptote. And it's approaching it from the top. So -3 from the top. Beautiful. Louisa, beautiful. All right, B is a whole different animal. All right, B says x is approaching 2 from the left. Now, what's happening at 2? You got a vertical asymptote, right? And as you come toward that vertical asymptote from either direction, your choices are up or down. So what's happening as we approach 2 from the left? Negative infinity. We're going down. On the left side, we're going down. All right? Problem C is a whole different animal because we're approaching 3. What's 3?
Whole.
3 is a whole, right? So we just want to know what happens at 3. Well, as we come at 3 from either direction, it isn't going to matter, right? From either direction, because here's the hole, we're coming both directions. Where are we going? 5. 5. Remember, limits are y values. What is happening to y? Let's go into 5. All right, D is end behavior on the left side. What's the limit as x approaches negative infinity?
-3 from the bottom.
-3 from the bottom. We're approaching our horizontal asymptote, but coming at it from the bottom. And then E is, what's the limit as x approaches 2? That is our vertical asymptote. We're coming at it from the right. As we approach 2 from the right, it looks like we are going positive infinity. Okay? Now, those 5 problems were super easy, I think, because we had a picture in front of us, right? So what do you do if you're asked the same 5 questions, but all you have is the equation? Probably sketch it, which is what we did the very first thing, because once you get it sketched, you can answer all kinds of questions about it when you're looking at it. Okay? All right. We're gonna wrap up here. We started this with the other group yesterday, but they only had about 5 minutes like you do. So this exercise is a cool little thing put together by Mr. Passwater. I'm gonna explain to you how it works, and then we'll work on it again next time. You got 2?
Yep. Before, can I find like more of these review problems anywhere?
Yeah, Mr. Password.
Notes. Okay.
Okay. All right. Now here's how this works. Odd one out. You can separate the pages if you wish. Okay? Because you're really going to need to do that to do the problem. So you've been given 3 functions. Function g of h. Okay? And now you're going to answer these questions about those functions. So problem number 1 has 3 parts, 1a, 1b, and 1c. You answer each of those questions. So you find g of 4. You find the limit as x approaches negative infinity of f of x, and you find g of -2. All right, so you're gonna have 3 separate answers for number 1. 2 of them will match. 1 of them won't. That's called the odd one out. It doesn't match. Then you do the same thing for problem 2. 3 parts to problem 2. 2 of them will match. And then so on through the list. When you're all done, you're gonna go back and find, this is where you can write your answers. Your answers can be written right here. You're gonna go back and add up all your odd one outs, and hopefully we all get the same answer. Okay, so you understand how it works? We'll work on this some more next time, but you can go ahead and get started on it now.